Okay. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Uh, Dear authors and invited guests, welcome to Technical Session 5C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology. The eighth edition of this conference is organized in the hybrid mode. Physical mode is already ended, and the digital mode is today and the yesterday. Okay. And now, I hope all the participants will enjoy the knowledgeable and interactive sessions through the day. And that is special note for the presenters. In this session, we have six presentation, and each presentation will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder so you can recapitulate your presentation. And there's one another request for all the participants that you may please all stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. And if you have any query or any update, you can write it to me in the chat box. Just before we get started, I just want to introduce you all to the chairs for the session. Dr. Parikshit and Mahale and
Hi all.
Dr. Roshan G. Regil. Just before we start, I would like to give some short intro about our session chairs. Dr. Parikshit and Mahale is a senior member of IEEE and is a professor and dean of research and development and head of Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Information Technology, Pune, India. He has 23 plus years of teaching experience and research experience. His research interests are machine learning, data science, algorithms, Internet of Things, identity management, and security. And if I talk about Dr. Roshan is a full-time professor in computer engineering at the University of Pennsylvania. He is a skilled university lecturer and researcher with a doctorate in computer science and engineering and a passion for teaching, research, and administration. His research interest is in the areas of fault-tolerant and dependable computing, accelerated and high-performance computing, variable computing, and synthesis of secure and reliable embedded processor. Uh, okay, then. Thank you, sir, for your valuable presence over here to chair this session.
Thank you.
And now we start with the papers. Our first presenter is Bill Caracastas, and he's going to presenting on a digital twin enabled decision support framework for ship or operational optimization towards decarbonization. Dear presenter, you may please start your presentation.
Okay, I will start. Good afternoon. Can you hear me?
Yes, we can hear you.
Yes, excellent. Okay, I need to share my screen, I suppose. And
Yes,
this is my presentation. So start from the beginning. Okay, so again, good morning. And my presentation is titled Digital Twin Enable Decision Support Framework for Ship Operational Optimization Towards Decarbonization. My name is Bill Caracostas, and I represent the Inlecum Group, and I have co-authors from some other organizations as well, as you can see in the slide. So without more hesitation, let's start. What I'm going to talk about is first introduce the project that sponsors this research called DT4GS. I will then talk about green shipping, and then about digital twins, and then about what are the knowledge graphs and how they're used in digital twins for green shipping. I will give an example of a knowledge graph for ship digital twin, and I will conclude. Okay, starting with green shipping and decarbonization. I don't know if you have heard these terms, but they're very, very popular and important these days. And green shipping is a part of the overall strategy to reduce gas emissions, greenhouse gas emissions, but this is about ships. So it is a strategy that's been coordinated by the International Maritime Organization, and it has some goals, has set some goals to reduce the CO2 emissions of international shipping by at least 40% by 2030, and at least 50% by 2050 compared to 2008. So how can green shipping can achieve that, the decarbonization? There are several initiatives that try to achieve this decarbonization. One of them is a project called DT4GS, and it is a European Union-funded project that, as you can see in this slide, started last year, 1st of June. It will run for 3 years, and it has 21 partners, including universities, research organizations, shipping companies, and so on. You can see all the details there. My organization coordinates this project. And what we are going to talk here in this presentation is some research carried out in this project by INLECOM. Okay, so let's move on. See first the objectives of this DT4GS project. So its objective is to use digital twin technology, which I will explain what it means, to support the accelerated transition to zero emissions for shipping. So it will create a digital twinning infrastructure for shipping that will focus on optimizing the ship voyage performance, and then examine different decarbonization technologies to reduce emissions, and also examine technical and economic aspects. So this has to be obviously a synergetic attempt by shipping companies, by shipyards, by equipment manufacturers, class societies, ports, and so on. Okay, I don't know how many of you have heard of digital twin, but the concept is very popular these days, although it's not a new concept, but it's been around for many years, but it's been more popular recently, as you know, due to other factors, other advances in IT. So a digital twin is a representation of a physical entity, in this case, a ship, in a digital format. A digital twin is used in place of its physical counterpart to carry out simulations, to analyze data, to make predictions, to predict outcomes, and improve the performance of the physical product, in this case, the ship. Okay, so again, another important concept here is the knowledge graph. And again, I don't know how many of you have heard of this, but again, it's a very recent, very trendy information management concept. So a knowledge graph is a layer of interconnected data that are enriched with semantics and are used to support complex decision making. So effectively, a knowledge graph is a model that connects concepts, entities, relationships, events, and uses also links, uses semantic metadata, and it supports data integration, supports data unification, analytics, and sharing of data for business intelligence. What is the relation between knowledge graphs and digital twins? Simply, the knowledge graph provides the infrastructure to support the digital twin, to implement the digital twin. So, as I said before, what is a knowledge graph used for? It is used for simulations to carry out what-if scenario analysis. It is used for problem solving and troubleshooting of complex systems. Complex system can be a factory, or it can be a car, or a ship in our case. It can be used for predictive maintenance, which is again a very important concept in manufacturing, and means the ability to fix problems in a system before they occur, and to avoid catastrophic consequences, the system collapsing, going bad, and to reduce costs in general. In this project in DT4GS, we are using knowledge graphs to support the digital twin analysis and to see how does the digital twin work and what would be the optimal way to make it work. I mean, in terms of performance, in terms of green performance in particular. We'll see an example in a second about knowledge graphs. So this is a model of a ship effectively. As you can see, all the circles correspond to models about the ship and to variables that we want to monitor and analyze. So you can look from left to right and read the different names of the nodes. So the important thing here is obviously the nodes that represent models of the ship that, for example, correspond to the ship engine or to the ship hull or to the ship's other subsystems. And then you have variables that they monitor and they represent the characteristics of a subsystem. For example, how fast the speed is, the engine is rotating, the speed of the engine rotation, things like that. Now, the important thing here is not just the individual models and variables, but how they link to each other. And they link to each other with some links that represent the effect, the cause effect between different models and variables. Ultimately, moving to the right of the screen, linking to some parameters that we were interested in, like as I said, the green performance of the ship. So this configuration, what is this effect on the performance of the ship? How green does it make the ship? How much does it reduce the ship emissions? So the idea is that this model now is used to simulate and analyze different scenarios about how the ship can be configured with green technologies to analyze the different options and to see which is the best way to improve the ship's performance. So this is really what the knowledge graph is about, and this is what the digital twin is doing. So instead of analyzing the real ship, which is very difficult, obviously, especially if the ship is not ready yet, it's just a design, you analyze a digital twin and you explore and investigate the different options for decarbonization and see which technology works best. Perhaps I didn't mention what is the decarbonization technologies, but you probably have already guessed is the same technologies that we use in other industries, and these are the technologies that provide energy from the sun, from the wind, from the sea even, and also from some new fuels that are, for example, the new green fuels like hydrogen. So we'll look at the different technologies and how this affect the performance of the ship. Okay, so part of this digital twin then is this optimization engine that you can see here in a block diagram of the different systems of the engine. So the idea again is that we analyze the operational conditions of the ship, and we, through this digital twin knowledge graph, we analyze the effect on the different performance metrics, the CO2, the cost, also the costs are very important, the cost for the ship, for the buying the ship, configuring the ship, and so on. Okay, let me see how I'm doing for time. I only have a few, very few minutes left. Yeah. Okay, so this gives you obviously an idea. Obviously, this engine is still under development, so it has not finished, but it gives you an idea of how you can use a digital twin of a ship to make the ships greener. So in conclusion then, what we can say is that the digital twin is an enabling technology for green shipping. In this project, we try to prove that this is a very important technology to support green shipping, make ships more environmentally friendly. A digital twin requires integration and fusion of heterogeneous data that originate in diverse systems. So this is why very important, because the data about the ship come from different areas of the ship and different environment, like the sea, the wind, and so on. We use the knowledge graphs that are also very important technology for making digital twins, and they add insight to the underlying structure of the data. In our project, we have a knowledge graph to interlink data and models of the ship, as you saw in the example previously. This model we use to optimize the ship's environmental performance. And we are developing a decision management capability for selecting, combining green shipping technology. So what is the technology that works best for the ship, for a particular type of ship, for a particular mission of the ship? What technology can we use? Is this the wind power? Is it some other technology? Is it green fuel? How can we combine them to make ships more environmentally friendly? So this is what are currently doing. The project has been running now for a bit over a year, so we are in progress of creating the knowledge graph and digital twins. Okay, I'd like to thank you for listening, and if you have any questions, feel free after this session even to email me at my email address that you see here. So thank you very much.
Thank you. Thank you for nice presentation.
Yes, questions or other comments?
Yeah, I have a small question. Can you hear me?
Yes, yes.
Okay. Can you justify why knowledge graph is required for digital twin?
Yes, because the digital twin uses different types of models. These models are models, physics models, they are mathematical models, they are data-based models. So you need something like that that integrates heterogeneous types of data. And knowledge graph is very good in integrating heterogeneous types of data. That's what is important.
Okay. Fine. Thank you. Over to Professor Roshan.
Thank you.
Yeah, thank you for the presentation. It was really
Thank you.
interesting topic. I don't have any specific questions. So good topic. Yeah. Thank you.
Thank you.
Okay. Thank you, dear presenter, for your valuable presentation. And now I'd like to invite our next presenter, Asif Hassan Chowdhury, and he's going to be presenting on a hybrid federated learning based. Just a second. Okay, he's going to be presenting on a hybrid federated learning based assembled approach for lung disease diagnosis, leveraging fusion of SWIN transformer and CNN.
Hello, everyone. Am I audible?
Yes, sir, you are audible.
Okay, let me share my screen. Is my screen visible to everyone?
Yes, it is visible.
Okay, thank you. So thank you everyone for the opportunity to allow us to present our paper here. So our topic is a hybrid federated learning enabled ensemble approach for lung disease diagnosis, leveraging a combination of SWIN transformer and CNN. I am Asif Hassan Chowdhury, one of our group members, and thanks to our other group members, Fahim Islam, Riyad, and Fayaz for helping us to develop this research work. And special thanks to our Professor Golam Robil sir and also Tanjim Reza sir for guiding us to work under our interest. So the research motivation, we have actually we are actually talked about a very known incident that happened back in 2020 and 2021, the coronavirus pandemic. It was a very devastating situation for all of us around the world. We have been to some serious mental, physical, economic, and social impact for this pandemic. We lost a lot of close people, and we have been through a lot very difficulties around the world. Like many other countries, Bangladesh had very difficult time in that situation. Like many people lost their jobs, and many people died because of this severe pandemic. So when we actually started our first research work, we are actually looking for some topic that what we can do, and then our group mates actually talked about that why don't we actually try to contribute our computer science knowledge to address some medical challenges. If we can do something to address some medical challenges. So from that perspective, we actually interested to choose the topic that different lung disease diagnosis detection system based on the X-ray images. So beside that, we also know there are a lot of children and aged people die because of pneumonia, and also we know that we have been through the era where the data privacy is very essential part of the system. So beside our lung disease detection system, we actually thought about that how about we can actually address the data security issue as well. So that's why we actually use the federated learning concept in our research work. So before starting work on our interest, we actually went through several papers that actually helped us to understand that how the different CNN algorithm works and why we actually going to use them. So we have been through different papers and different algorithms discussion like VGG19, DenseNet 201, Inception V3, and ResNet. And also, as I already talked about, that we actually used the X-ray images. So it was very important that we are actually understand that how image processing works behind the wall. So we have been through some papers as well. Then we actually, I have already discussed that we actually used federated learning for our data privacy. So we have been through some papers of federated learning based, and also we already talked about that our system actually using the transformer based learning model. So we have been through some papers as well. So let's get into the work plan diagram. So here we can see at first place that our we collected the X-ray data, then we have been doing some data pre-processing, and right after that we actually have COVID-19 data set, pneumonia disease X-ray data set, and normal X-ray data set. So right after that we actually train those data through different models like VGT19, Inception V3, and DenseNet 201, and then we actually combine those trained models and developed an ensemble model to understand bring the uniqueness of the system. That okay, so we have that different trained models and we combine them, and right after that we have a combined model that actually help us to be even more accurate in order to detect the disease. And right after that, you can see that main hybrid ensemble model, that actually combination of a transfer model and transformer based model, which is swing transformer and the ensemble model, that is combining together to create our hybrid model. So this hybrid model is actually working as the main backbone of this federated learning environment, where you can see the centralized system is actually holding this model, and the different hospitals actually have the data set of different X-ray images from their COVID patients or pneumonia affected patients. And when those hospitals actually have the individual training system, model training system, they will also be through this training procedure, and they will also generate some outcome. And based on that, we actually select the best model to select as our central model, so that we can actually compare and decide that whether the data set is whether the patient is actually suffering from COVID or pneumonia, or whether there is no disease of this patient or some other disease. So as we talked about our proposed system, the basic fundamentals that we actually used here is that as first we created the model, then we had to work with our image data set, that is our X-ray data set, and lastly we have the result that we actually going to discuss further. So we have as we already know, the sequential model is actually the backbone of most of the CNN models today. So also we had to work with some other convolutional layer and dropout layer as well, and the optimizer, so that we actually understand that how our own developed improved model actually working with our data set. So as we are continuing our proposed system, we have to collect our data set. It was a very challenging task to collect data set. At first, we actually tried to collect our data set from the different hospitals, but Then we found out that hospitals are not very eager to share their data because of the privacy issue. So next we actually started to look for the data from different sources, like different papers who actually already started working on the COVID disease and other pneumonia or other lung diseases. So we actually depended on the secondary source of the data collection process. Then we have been through the regular process of training the image or maintaining the validation set and other classification techniques. So I'm a bit sorry for the overview of this slide, because it's a bit it's a bit difficult for you all to view what is happening here. So I'll be with you to describe what is actually discussing here. So you see that we at first will collect the data set, and right after that we have trained each an individual model with our data set. And right after that, when we have a trained model, we actually combine them and created a hybrid model. And this hybrid model is actually transfer learning based model, because the model that we have used, VGG19, Inception v3, and DenseNet 201, is actually represents the transfer learning models. And when we have the hybrid transfer learning model, right after below you can see that we actually used another model, which is transformer based model, which is developed by Microsoft, which is shifted window or swing transformer model. Thanks to Microsoft for developing a model like this. So right after that, we actually combine those two models, like hybrid model and transformer based model, to create our ensemble hybrid model. So here it is the ensembled hybrid model. Then we use this model as our central federated server learning model, because this is the model that we actually proposing is very so far that we worked on. We actually developed this model in a way that actually this can help us to be very cautious about the prediction, because it's because depending on this model, depending on this model, we're going to identify whether the patient is suffering from COVID or pneumonia or not. So we can also see there are different hospitals that are also part of this network. So what will happen here is actually these hospital will also have different models, and based on their data set, they will train their own individual models. When these models will be trained, like let's say, think about a scenario like hospital C has more data set and they actually train better. They are actually having better hybrid models. So what will happen? Then we will actually change our central model, and we will actually make the hospital C model as our main central model, because this is actually performing better over the different data set. So we actually kept the environment that where we actually ensure that best models are actually getting the opportunity to identify the disease. So here is a glimpse of our data set. You can see that COVID infected lung is actually having very hazy images, and also the pneumonia, and the normal image X-ray image is normal patient X-ray image is bit clear to view. So here we have talked about some models that we have used, like VGD19, Inception v3, DenseNet 201, Swing Transformer model. And right after that, we created a hybrid model that we already talked about, transfer learning model, which is based on this VGG19, Inception v3, and DenseNet 201. And the fusion model, which is the combination of the transfer learning based model and the Swing Transformer model. So this is the overview of it. So let's move on to the adjustment that we have been through during our research work. So we have used the image shape of 224 into 3, and we used the batch size of 25, and our backbone architecture was sequential model. Apart from that, in order to avoid the overtrain issue, we actually made the middle layer trainable false, and also we have adjusted our drop out layer 0.5 so that we can avoid the overfitting issue. Then we have used some basic CNN principles like batch normalization layer and a global average pooling layer and dense layer with ReLU activation function overcome the negative learning problem. So we actually also had some other training configuration, like we have set the epoch to 30 and early stops patient like 5. Like you already know that early stops patient is actually used for to see that if the result is not improving, then we will actually use that we actually stop that training procedure. So here we can see as inception V3 based outcome analysis. Here we can see that with all these careful steps, we have found 94.5% of categorical validation accuracy during our training time. And also our training accuracy is 98.6%. And we are also showing the model loss that we have been encountered over the time. Next, we have trained our dataset using DenseNet 201 model. This actually used almost similar training configuration as well. You can see that our dropout layer is 0.5 and batch normalization layer improved and use batch normalization layer for our better outcome. And here we can see that with all these careful steps that we actually maintain that our middle layer trainable false and dropout layer to 0.5, we have achieved 94.1% of categorical validation accuracy and training accuracy of 97.5%. So these are individually training. Now we can see that VGD19 based outcome analysis. Here we can see that we have found 94.4% of categorical validation accuracy and 96.5% of training accuracy. So as we already discussed that we have trained our all individuals models using using our collected data set, so that we can understand that how this data set and how this algorithms is working together to understand the idea of it. So lastly,
sorry to interrupt you, sir, but you
yes.
have last 2 minutes.
Okay, thank you. So here we can see that Swin transformer based configuration. We use the similar configuration here. This is a transformer based learning models, and we see that only using this model we are getting 82.5% of categorical validation accuracy and training accuracy of 83.85%. So this is a very obvious model planning. We can see that combining transfer model and transformer model to create our fusion model. Then we combine all this transfer and transformer based learning model to find out that we have achieved 97% of categorical validation accuracy and 99.15% of training accuracy. So you see that it's bit overfitting. We are very aware of this situation, because we actually need some more, around 10 to 20,000 more data to find out that whether it's actually overfitting on that moment or not. So we already started working on it so that we can actually avoid this overfitting issue. So here is another glimpse of it, that we are actually looking for the weighted average approach. So as we talked about that we have used the federated learning model, we see that there is not very stable outcome of this federated model based analysis, because we had some hardware related issue, because the huge data set is actually was very difficult for us to actually ensure that federated learning is working properly. However, we started working on to resolve this issue as well, because as we already know that every research work has its own limitations. So like other we had also. So here is a side-by-side confusion matrix based comparison of our result, you can see. And lastly, we have some tabular comparison that actually showing that how each different model actually performed in using our data set. So here in the conclusion, we are actually working on currently to address the issues that I have already talked about earlier. And also we are actually working on to address the issues like federated learning based concept drift problem, and also we already talked about that we have some overfitting issue as well. We started working on that. So thanks for the time and patience for listening to our research work. Thank you, everyone. If you have any question, you can ask.
Yeah, thank you for good presentation.
Thank you, sir.
Yeah, in the last slide where you have compared your results with other techniques, are other techniques also using federated learning, or they are only using simple machine learning?
Okay, sir. So the thing is that we actually talked about that our combined model is actually based on the federated learning. That the combined model means that transformer based learning model and transfer based learning model. This is the complete model. So we use that model to in the federated learning environment.
Okay, so in your case, data is non-collocated or data is at same place?
So, sir, at this point, the data is distributed, like as I already discussed, that the different hospitals will be holding the data. So we are not actually.
In your case, actually, when you had done training, data, it was a local data set, or you have collected data set from multiple non-collocated sources?
Actually, sir, we collected the data from multiple non-collocated sources, like as I already talked about.
Thank you. Okay, we can.
Thank you, sir. Thank you.
Okay, thank you. Good presentation. I have a couple of questions. One, you were talking about training accuracy. Is it how did you measure? Is it like some part of the training data used for testing? What do you mean by the training accuracy?
Okay, sir. So in order to ensure the training accuracy, actually we have used, as I already discussed, we have used around 9,000 of
Yeah,
data
that's
during
clear.
training. So
Yeah.
training accuracy is actually when the model is trained, and the validation accuracy is actually identify that whether the model is actually behaving correctly or not. So validation set, as we already know, it is not shared with the model, so that we can actually avoid the overlearning scenarios or some kind of thing.
Yeah.
So
have you?
Yes, sir.
So the data, when you do these experiments, are you using the same group of data for training and also validation, or are you using different sets from different
Sir,
places?
we have used a different set for the training and for the validation.
Are they from different hospitals?
Yes, sir.
Or same? Okay.
Yes, sir.
Right.
For different sources. Yes, sir.
Okay. Thank you.
Thank you, sir. Thank you, sir.
Okay, so moving for our next presentation. Our next presenter is Hasrini Sari, and she's going to presenting on a can start video ads evoke empathy.
Okay, thank you. I want to share my presentation.
All presenters are requested to stick to the timeline, please.
Can you hear me?
Yes, we can hear you.
Yes,
Yeah.
okay. Thank you. Thank you for the opportunity to present our paper titled Can Short Video Ads Evoke Empathy? We are from Indonesia, from Institut Teknologi Bandung. So as we all know that currently there are many platforms that allow the audience to upload short videos, and many companies use it as to advertise their products. So based on that conditions, we try to study some previous paper. We found that if the image being viewed in a movie or video, the viewer can feel the emotional effect after watching the movie or video. Short video advertising has a significant direct relationship with sales, and the same video seen evokes different emotions in different individuals. So we formulate our research objective to investigate factors that can evoke empathy in viewers after watching a short video. We define empathy as a person's emotional response based on that person's understanding of another person's emotional stimulus or emotional state. We find there are two kinds of empathy: trait empathies, a person's fundamental nature, and state empathy arises because of certain conditions, including information. We also collect some literature about brainwaves, and we found there are 5 types of brainwaves: gamma, beta, alpha, theta, and delta. Each of these types of brainwaves can be triggered by different emotion. For example, theta brainwaves can be triggered by anger, surprise, and sadness. So we formulate our research question as: can a short video post on Instagram evoke the state empathy of its viewers? We formulate 3 hypotheses. The first about the effect of location in the video, and the point of view of in the video, and the audio used in the video. We control several variables, namely the story, the actor or actress, the duration of the video. We use 8 seconds. As a case study, we use a short video uploaded in Instagram by a cafe located in Bandung. Indonesia, the video intended to evoke an empathy from its viewer. So we conducted an experiment design using eye tracker, muse band, and questionnaires. Eye tracker we used to measure eye movement to test hypothesis 1 and 2. Muse band to measure brain waves used to test hypothesis 3. And questionnaire we used to measure empathy as the dependent variables. For the design experiment, the experiment design, we have 3 factors. Each has 2 levels, as you can see in the table. For location, we have a stimuli that show the video happen in outside of the cafe, and the other is inside the cafe. And for the point of view, close to the main character, and the other stimuli close up of the supporting character. And audio, there is stimuli without audio, and the other with audio. You can see the picture of the video. The left one shows at outside the cafe. The location is outside the cafe, and the point of view is to the supporting characters. And at the right picture shows the location is inside the cafe, and the point of view focus on the main characters. We developed 8 stimuli. One of them is the existing video as a control stimuli, and the minimum number of participants is 30. Data collection we conducted in our campus laboratory. We test the validity and reliability using Pearson correlation and Cronbach alpha, and all of the indicators surpass the minimum value. And then we proceed to the data normalization using a min-max method for data collected from eye tracker and muse band, because they have different data types. And then we calculate the gap value between trait and state empathy to find the difference of before and after seeing the video. And then we also conduct a normality data testing using Kolmogorov-Smirnov test, and we found that the data is not normally distributed. So we use robust regression to analyze the data, and the result shows that the R-square is 8.35%. This is relatively low, and also if you see the table below in this slide, you can see that the location is not significant. 2 variables are significant, audio and point of view. However, the coefficient of point of view is negative. We guess that it because the equation indicate that the participant give more attention to the main character when the video shoot close up of the supporting character. And also we compare the participants' empathy level before and after seeing the stimulus using paired t-test. And for the point of view variable, we found out that the differences are not significant between the 2 different point of view. Therefore, we conclude that the stimulus design using the main character's point of view cannot evoke a significant different level of empathy from the audience relative to the existing video as a control. And for audio, the stimulus with audio differs significantly from the stimulus with no audio, without audio, where the mean value for audio is higher. We also do a literature study, and because of the R-square of our equation is relatively low, so we suggest that for further research, we can involve other variables, namely lightning, color, and duration of the video. So in conclusion, audio and point of view are significant in evoking empathy. However, the variance explained by these 2 factors is relatively small. And further investigation shows that the gap in empathy level before and after watching the video is not significant for stimuli with a different point of view. So the only significant factors that can make a difference in the level of empathy for the participant is audio. Thank you for the attention. Please, if there's any question.
Yeah, your topic is very good. Just I have a very small question. Have you implemented this entire research?
Pardon me?
Have you implemented this research?
Yes.
Have you done some implementation?
Yeah. We haven't do the implement. We have the video that we use for the case study is actually a real video. I mean it really posted in the Instagram of the cafe, but we haven't modified the existing video to because the existing video with no audio, so the control stimulus without audio, so we have to make the video we have to post the video with audio to see whether there will be a different response from the followers or the viewers.
Okay, good. Thank you.
Thank you.
Okay, so since there's no question, we're moving for our next presenter. Our next presenter is Hurma, and she's going to presenting on improving the resume verification process of financial professionals using blockchain smart contracts.
Hello, can you hear me?
Yes, we can.
Yeah.
Okay, I'll share my screen then. Yeah, can you see?
Yes, we can see it.
Okay. Hello, everybody. Thank you so much for coming and joining. It's a pleasure to be over here and presenting this. So we're going to be presenting about blockchain technology that is used for verifying financial professional resumes. So the recent technological advances have made it much easier for the validation and the compilation of accounting and auditing resumes. Whereas before, it used to be very time consuming. It used to lack a lot of formal interaction, and it was very prone to forgery. As a result, there was a lot of unethical behavior that was infecting the profession that was growing. With the help of blockchain-based solutions, the membership application processes can be automated, which will result in quicker verification and reduced paperwork. Furthermore, this approach will also eliminate the risk of unethical behavior, and it will support the growth of this profession. So to dive into the objectives of our research, we have two main objectives. First is the creation of a private blockchain architecture. And second, we developed a smart contract algorithm that will improve the verification process for professionals' resumes. So our proposed blockchain approach takes into consideration blockchain and smart contracts. So the smart contracts protect both financial and non-financial data, and our transactions that we're going to have within the blockchain are encrypted, which will keep our entire technology very secure. And moving on, the data that we have, it will be immutable. It will not be able to change, which will make it more safe. Comparing this to the traditional way of checking resumes, the employers might not have been able to detect any fake degrees that were given in, and this was affecting the profession. So to protect this, we have financial specialists which will verify the member data, and we have the smart contracts on the blockchain, which will make the terms and the conditions of the contract much easier to understand, and it will reduce the disagreements. Furthermore, the reputation of the financial experts will build this way because the smart contracts will keep property of all documents, which will cut down the waiting time that it takes for verification of documents. And lastly, we have the security issue which happens. So this will be protected against DDoS attacks, consensus manipulation, MSP compromise, and all the problems that have with blockchain-based hyperledgers will be avoided with our security intelligence measures. So this is the architecture of our proposed system. It has multiple different things, but three different categories, if you may. First, we have the end users, then we have the application that itself, the blockchain application, and then lastly, we have the blockchain network. So these are the three key elements. Speaking of the end users, they're divided into, you could say, 4 to 5 different types. First, we have the regulators. These can be any local accrediting organization, which will verify the resumes of the members and which will recognize their expertise. Then we have the validator. So this is your employer, accreditation body, university, or government agency, which is going to check for identification, qualification, and work history. Then we have the workers. These are basically the people who want their resumes to be verified through the system. And then lastly, we have the admin, which is just controlling the whole platform. Moving on to our web application. So this is the website that's going to host the solution. It's going to record transactions, and our client, which is the end user, can access it through an HTTP browser on their computer, mobile device, through anything. They can connect to this web application. Moving on to our membership services. So this is a node which identifies the network's usage for the business transactions. So our open source Hyperledger Fabric will verify the network participants, and it will control the whole transactions happening within the system. Then we have our peer. So the peer, it stores all the ledgers and the smart contracts that will record all the transaction information and procedures, and it will establish or delete peers based on whatever is going on in the system. So they will basically deliver your chain codes and your ledgers to the administrator and to the programmer, making it a really crucial part of our entire system. Then we have our ledger itself, which is going to store all the product information and the data of the product. And then lastly, we have our chain code, which is basically used for governing information, and the user agreements and all the designers, they will all have a set norms that they're going to follow. And if somebody breaks these norms, they're going to be kicked out of the blockchain system. So this is where your chain code works in. So the workings of a system will be better illustrated when I give you an example. So let me just give you an example. Let's assume that Majid is a recent accounting graduate and he's looking for a job, right? And he's looking in the job market. So let's presume that he already has certifications from his university, like he has a bachelor's degree or a master's degree, and he has other professional qualifications like CPA and CFA. Those are accounting and auditing. So all of these certifications, of course, will be coming from different bodies and different countries. So for every application that he makes, he'll have to attach to certification, and then the hiring company would have to verify their authenticity. So our proposed architecture unifies this entire verification process. So upon getting his certification from the professional body, Majid will receive a non-fungible token that is non-transferable between individuals. So this token is going to represent all the underlying certifications that are already authenticated with Majid, and that's going to start a transaction within our network. So once the transaction is started, it's going to start from two ends. One is Majid and the other is the hiring company. So the transaction will contain everything. It will contain his degree. It will contain the CPA and the CFA certification, all of them already verified by the professionals. So every professional organization in the network is going to represent a node. So for instance, the CFA institution is a node in our network. So then we have the regulators, which are going to give permission for the underlying smart contracts. Since all of the professional organizations are in the network and they're nodes, so they can either accept or reject the transaction that's happening. So now Majid is going to have a whole profile that's going to show all the existing certifications and their statuses. And of course, we have the Hyperledger, which is going to work in a decentralized way for this entire verification system. The distributed ledgers that we have with each peer hold all the transaction logs and the peer accessible state information. And then we have one network-wide log, which is going to have data in a non-centralized database. Speaking of, we did a performance analysis on our system. So the analysis represents a single peer network with a varying number of transactions. So the entire network that we created for this analysis was just, it had one peer and a whole transaction happening. So we wanted to transactions would happen, and would these transactions be able to work properly through the system. So based on the analysis of the data for the performance of the Hyperledger smart contracts, we had a lot of metrics decided, including the scalability in terms of time, latency, and throughput. So the time is the duration between the transaction from being deployed to the duration that the transaction was completed. Then we have our scalability in terms of how many number of transactions were on the system. The execution period is the time that it takes for the Hyperledger to execute a transaction. So the difference between the maximum and the minimum time. We have the latency, which refers to the time difference between the deployment and the completion, or you could say that the average of all of the transactions in the data set. The throughput will refer to the successful transactions that happen in 1 second. So the API that we have, the REST API tool, we use this was applied for the analysis, and the REST API tool basically gives immediate feedback from the transactions, which allows us to understand that our system is working properly or not. And the success in resume validation through the blockchain initiative relies on the Hyperledger Fabric networks that are accommodated with the peer network topology anchored on the edge computing, which provides security, identification, management, and authentication services of all of these documents. So the study relies on the built multiplayer platform that we created on the blockchain technology itself. So the application consists of a lot of different types of users, which have different stories. Sorry. So here we have a comprehensive user stories model, which describes the user access and their roles for the system. So first we have the worker or the student. This is anybody who's going to join the network using a web application or a web browser. They'll be able to identify their credentials, employment histories, professional certification, training programs. All of these things will be utilized to verify their resume. So the employee would be encouraged to join a regulator who is in their location and in their line of work. Then the worker will become eligible for a membership within the system. Then the system is going to compare their qualifications, professional certificates, and their job certifications. Then, of course, we have the regulator. So the regulator is going to have the ability to create and verify these memberships, as well as view all the members that are in the same profession and the same location. They're kind of like the administrator for evaluating the members, their documents, all of this stuff. Then we have the second type of user, which is the employer. So the employer is going to be somebody who's going to create workers' employment histories. However, if they create an employment letter, they're going to have to get it approved by the employer administrator. So just like this, if we have a university who has certifications and stuff, so if they create or verify worker qualifications, they need to get it certified by the administrator as well. So in conclusion, we can see that businesses are beginning to recognize the potential that blockchain has. And as we know from the past, that document verification processes were really slow, they were burdensome, and honestly, they were not really moral in this sense. So the objective of our study was to develop a distributed ledger platform for document verification. We used Hyperledger Fabric, which enables user authentication and secure blockchain transactions. And the architecture that we had produced transactions that support peer-to-peer message transits, which will create a more secure network. Furthermore, the Hyperledger minimizes the cost of human application evaluation. It encrypts your transactions and documents against any DDoS attacks. And lastly, the Hyperledger technology is ideal for verifying documents because it solves the centralized and the manual document verification problems, and it will facilitate effective communication and expedite any decision making. Thank you so much for listening.
Thank you for nice presentation. I have only one small question. Have you created these attacks or have you used any attacker model?
No, for the attacks, we just, because we already use the blockchain technology, we already use it for previous projects as well. So we just know that it's, you could say it works against these attacks. So we just tried a couple of attacks and we got the results that it was tested.
Yeah, I agree. But have you created these attacks? How you verified?
Sorry?
How you have verified against attack? Have you created these attacks?
Yes.
How you
we
created
created a DDoS attack through the system. we tried to basically barge into the system through a DDoS attack, and it was able to kick us out of the blockchain altogether.
So on which platform you have created DDoS attack?
Hello?
On which platform have you created DDoS attack?
We basically tried to have a lot of different computers trying to log into the system together. So
Okay.
that's how we tried to see the DDoS.
Okay, thank you very much. Thank you.
Can I ask a quick question? You have time?
Thank you.
Do you have time for a question?
Yes, sir, you can ask.
Yes?
Yes.
Okay, can I ask you quickly then, why do you choose a private blockchain instead of a public one?
Because we wanted it to be more secure in this sense. With the public blockchain, you would be giving out public keys. We wanted this to be more secure. We created this blockchain technology basically for a particular company. So that's why we had to create it as a private blockchain application rather than a public one. Maybe in the future, you could change it to a public blockchain.
Okay, thank you.
Thank you.
Okay, so
Can I ask a
going
question
for
if it's possible?
yes, you can.
Yeah. Sorry about that. I just wanted to know because according to you, the verification of credentials, right? I mean, the resumes or certificates is still done manually by a trusted official, right?
Yeah.
Is there a way you can automate this?
Yeah, that's what we tried to create through this blockchain technology, a way that even with the blockchain technology, actually, it's somebody who is verified. He's the one who is checking it, but it's just making the process a lot more quicker. To automate it, because within automation, it would be that you would have to get like a lot more, maybe if you create an AI that detects the falsification happening or the forgery happening, maybe then you could have an automation of certificate verification. But as of now, I feel like even AIs probably would not be able to differentiate between the fake documents that come into the system.
I mean, yeah, I mean, it's still, I mean, this verifiable credentials has a lot of scope. So I think implementing GANs or CNNs might be able to help.
Yeah, definitely.
I'm not sure. Yeah.
We have another project going on for CGANs, which have a lot of potential. Maybe we could use that to see like the fake documents or see the difference between documents that are real and fake. And maybe that could continue to make it automated. Yeah, definitely.
Great presentation.
Thank you. Thank you so much.
Okay, thank you dear presenter, for your presentation. Now I'd like to invite our next presenter, Aditya Subhash, and he's going to be presenting on robust keystroke behavior features for continuous user authentication for online fraud detection. Aditya, you may please start your presentation.
Yeah, am I audible?
Yes, you are audible.
Okay, so I'll just share my screen. Can you see my screen?
Yes, we can see your screen.
Okay, so good to know. So first of all, greetings to the chair and the organizers. It gives me great honor to speak about my paper titled Robust Keystroke Behavior Features for Continuous User Authentication for Online Fraud Detection. So moving on ahead, these are the topics of discussion. I will be telling you about the introduction, identified gaps, aim, overview of methodology, results, experiment, and conclusion. Now, when we talk about keystroke behavior or keystroke dynamics, we refer to a method by which we can identify users using by the way they type or how they use a keyboard. Now, keystroke dynamics and this field has been gaining a lot of popularity primarily because it provides non-invasive user identification. And it is also considered a more secure alternative to current authentication systems. On top of that, it can be used in multiple applications, including digital forensics and online assessment cheating, to name a few among various other applications. Now, despite this popularity, there are a lot of gaps in research. Number one, there are less methods that provide non-invasive continuous authentication for online education platforms, resulting in more network intrusions and online assessment fraud. Existing keystroke behavioral authentication methods also rely on fixed sequence of characters or static data for their analysis. Thirdly, majority of studies still depend on typical machine learning algorithms despite advancements in deep learning approaches. Last, there's also a need to identify better set of features for continuous user behavior for identity theft and online assessment cheating. So the main objective of this entire paper is to identify a set of keystroke behavior features for continuous user authentication for preventing online fraud, which includes identity theft and online assessment fraud in online education platforms. Now, keeping in mind the problems, this is the methodology we will be following. First, we will perform a detailed review and statistical study to analyze the different keystroke behavior features and identify and evaluate a particular set of features for continuous user authentication for online fraud detection. After we identify, we will be collecting our own data, which will be used to extract the features and evaluate them. The third, then what we will then be evaluating the features using a proposed deep learning approaches, and as a comparative as an additional contribution, we will be comparing the proposed deep learning approaches with conventional machine learning approaches. Then we will also investigate the robustness of those features. The next slide, we will talk about how we basically identified the features and how the review went. Now, when we talk about after we conduct the review, we construct a feature comparison matrix, which is the table shown in this slide. The feature comparison matrix is constructed by considering recent study in information security, which include malware, phishing, intrusion, identity theft, and business email compromise. With the major focus on AI-based methodologies for attack detection. The feature comparison matrix was basically contained the summarized information of all these different types of attacks presented by nearly 175 articles. However, the feature comparison matrix which I've shown in this slide is just a shorter version of the original feature comparison matrix because our main focus is on keystroke dynamics. This table contains summarized information about features, approaches, and the type of datasets used. Now, from the feature comparison matrix, we were able to perform a comprehensive statistical study from which we were able to identify the most frequently used features. Specifically, these are the features which we are proposing and evaluating using deep learning approaches. These features include the release press time, press time, and the hold time. Apart from this, we were also able to identify that majority of studies still rely on machine learning approaches and fixed text keystroke data for keystroke-based authentication. Now we will go into what type of data we collected and the feature extraction method. So while collecting data, two main challenges were considered. One is what type of data needs to be collected and how much data needs to be collected. The first question we were able to answer with the help of the feature comparison matrix. Through this, we were able to confirm that previous research still relies on analyzing fixed text data for keystroke behavioral biometric authentication. These data sets contain data records that are collected from participants that are required to type a fixed string, which could be a password or a phrase multiple times. However, this data cannot be used for continuous user authentication, primarily because continuous user authentication requires users to be identified at regular intervals of time, and where the input also varies over time. So keeping this in mind, we decided to collect free-form keystroke behavior data by asking participants to play an education game, which contains online assessments. The second, we were able to answer the second question by understanding how previous research collected data. They collect data by requesting participants to write a given phrase or password several times, like I said before. And sometimes this data is collected over a long period of time, sometimes over 2 years as well. But keeping in mind our time constraints, we decided to collect data. By requesting participants to answer 4 assessment-like activities, which include 2 answer the question and 2 copy the text activities. Participants were also asked to type at least 100 words per activity. Overall, we were able to collect data from 13 participants from from India for our research. Then for extracting the features, we need to know what features we need and why we need those features. Now, based on previous studies, uh, based on our previous slides, we propose to use the most frequently used features. Based on now, we need to understand why we need these features. Now, on further analysis, we found that these features used as a feature set yielded greater performance of greater than 90% in studies that focus on fixed text keystroke data for analysis. On further analysis, it was found that most frequently used features used as feature set yielded better performance than that compared to other features for other research applications like digital forensics, etc. Now, to extract the features, we use the following procedure. We basically got the raw data in JSON format, which included the key press, the key release, timestamp, the press time and release time of key. We basically converted this in a more editable format using Python's inbuilt libraries. And the combination of each of these samples, which I told you before, forms a record. Then after that, all keystroke activities were taken and then were separately merged, forming the data set. Then matching records between the key release and key pressed was found due to the presence of repetitive keys. Repetitive keys record multiple key press events, but record only one key release event, which causes an imbalance between the number of records. Then to extract the features, we basically divide each user's keystroke into 5 character length records and basically extract the most popular, most frequently used features. Next, we go into the results. No, we like I said before, we propose to use deep learning methodologies for evaluating the most frequently used features. However, in order to prove that deep learning performs is suitable for the task, we basically do a comparative study between deep learning and conventional machine learning algorithms. The deep learning algorithms which we have chosen here include the CNN, RNN, and transformer network, while the machine learning algorithms include decision tree, random forest, and k nearest neighbors. Now, based on the table, it can be easily seen that deep learning actually performs much better compared to that of machine learning approaches. Now, based on the results, we can say that deep learning approaches are much more suitable for continuous user authentication for online fraud detection. Now, moving on ahead, like I said before, we also evaluate the robustness of most frequently used features. This is an additional contribution to the paper. So I will be explaining the process here. So we to investigate the robustness of features, we only consider the deep learning algorithms because we already know that deep learning is much better than that of machine learning algorithms, as we stated in the previous slide. In order to do this, we will be training the deep learning approaches with a publicly available data set having the same features as the ones we identified previously. And then we will be comparing the performance using our novel data, which we have collected.
So here,
specifically, we will be using.
Aditya, here you are comparing not the algorithm, but you are comparing the performance of the data set and your own data, which is pre-processed, right?
Yes, sir. Specifically, we are evaluating the feature set.
Feature set.
Yes.
Understood. You can go ahead. Go ahead.
Yes, sir. No problem. Thank you, sir. So now, as you can see, according to the analysis, if you look at the RNN algorithm specifically, you can see that the RNN algorithm achieves 81, 72, 71 accuracy, precision, and recall when trained with the CMU benchmark dataset, but achieves 89, 83, and 83 accuracy, precision, and recall when trained with our novel data. So this numerically, there's an increase of more than 10% in almost all evaluation criteria when novel keystroke behavior data is used for training. However, this is not seen in CNN and transformer networks. For CNN, if you look at the performance, it is very similar to one another using different data sets. However, the only problem is there's a noticeable difference in the recall. But in transformer networks, it can be seen that the accuracy, precision, and recall is very similar to one another when you're using different data sets. So according to the results achieved, it is evident that performance between deep learning approaches when trained with different data set containing the same features either have superior or comparable performance in most evaluation criteria, with minor differences in accuracy, precision, and recall. In other words, based on the result analysis, the frequently used features that have been identified for continuous user authentication for online fraud detection are robust as well as achieve satisfactory performance when they are evaluated using deep learning approaches. So this concludes my presentation, and thank you for listening. If anybody has any questions, please ask.
Thank you. Thank you. Everything is clear. Good
Yes, sir.
presentation and very nice slides you have prepared. Good.
Thank you so much, sir. Thank you so much.
Okay, so moving for our next presenter.
Uh,
Next presenter is Jane Christine, and she's going to presenting on yield prediction of maize using a random forest algorithm.
Harsh sir, this is last presentation, right?
Yes, sir, it is last.
Okay, fine.
Right, so allow me to share my screen.
Yes, please.
Okay, so good day. So I am Ms. Jane Christine G. Suarez, together with my co-researcher, Professor Luisito Lacatan, and we are going to present our research entitled Yield Prediction of Maize Using Random Forest Algorithm. Now, for the outline of our presentation, I'm going to discuss just a brief introduction, the general objective of the study, the conceptual framework, the methodology, the description of the prototype, the results and discussions, and lastly, the conclusions. All right, so data mining, which is otherwise called as data or knowledge discovery, is the method of evaluating and classifying data from previous prospect and encapsulate it into useful information. In the past, yield prediction was performed by considering the farmer's experience in a particular field crop. And it is interesting to note that farmers nowadays harvest not only crops, but also growing amounts of data. Now, in this study, the researchers utilized the data mining, machine learning classification, and the GIS-based model for visualization in the prediction of yield. Now, the minimum of 5-year historical data will be used as the training data set and test data set for the yield status. Now, for the visualization, a spatial map will be provided to indicate the location of high and low status of future yield. Now, for the objective of the study, the general objective of the study is to develop a framework that is in phase 1 and a yield prediction system in phase 2 that will serve as a basis for decision-making and implementation of policies, plans, and other projects of the Provincial Agriculture of Bulacan in the Philippines. Now, for our specific objective number 1 is to be able to identify the different agricultural parameters that influence the maize yield in Bulacan, Philippines. So the expected output is the data set and the variable importance. Now, for the second objective is to develop a framework for predicting the maize yield using random forest algorithm. So the expected output is the prediction model. And for our third specific objective is to evaluate the accuracy, reliability, and validity of the model in maize yield prediction. So the expected output is for validation, the precision recall F measure, the inter-rater reliability, the confusion matrix, Cohen's kappa statistics. And lastly is in phase 2 to develop a yield prediction system using the most appropriate programming tool. And the expected output is the yield prediction of maize and a GIS-based model for visualization. Now for the conceptual framework, we have here for the input, municipality, the year, the month, the type or variety of corn, the area planting, the production, the yield, the season, and the status. And then for the process, we have here the data mining process, such as the gathering of data, the selection of attributes, and finding patterns for prediction. And for the development model, we are going to make use in phase 2, the rapid application development. And for evaluation, we are going to make use of the accuracy and validity testing and ground truth validation. For the output is a yield prediction, which has a status of high or low, and the geographical information system for the visualization. Now, for the methodology, these are the steps involved in the predictive modeling phases employed by yours truly, the researchers. Getting the data, clean, prepare, and manipulate the data, train the model, test the data, and lastly, to be able to come up with a prediction model. Now, in getting the data, the researchers requested the maize accomplishment report from the Provincial Agriculture Office of Bulacan in the Philippines. The data set ranges from year 2014 to 2021. So in this step, all possible attributes used in the data mining discovery task in order to determine the target set will be then identified. So here in figure number 1, you can see the corn program accomplishment report prepared and submitted by the senior agriculturist and the provincial corn coordinator, Mr. Benigno G. Cruz. So for the clean, prepare, and manipulate data process for the pre-processing, so in this step, the researchers removed the outliers and we dealt with the missing values in the data, and significant attributes was determined in this step. Thus, all irrelevant values and attributes from the original data set was then removed. So here in figure number 2 is a sample accomplishment report of our pre-processing stage. So in training the model, so in this step, the researchers identified the most suited data mining technique or algorithm that can be provide the best prediction regarding the prediction of maize. So in figure number 3, you can see the WECA data mining tool that we have to use and the significant attributes in training the model. Now, in figure number 4, you can see the cross-validation weighted average for model performance comparison. Now, in this table, you can see that among the 4 test options, random forest using the cross-validation has the second highest accuracy percentage, similar to J48 and JRIP, while naive Bayes has the lowest accuracy percentage. All right, in testing the data, in this step, the researchers came up with patterns discovered in databases and presented in proper format that the data mining tool can be recognized. So here is a sample pattern visualization, a scatter plot using our test data. So in the prediction, in this step, the researchers conducted visualization of the database on the extracted models. The extracted knowledge will be used and be incorporated into the developed system. So this is just an example of a data visualization of high and low yield per municipality. So for the description of the prototype, this is what the yield prediction system would look like. With the status of low or high. And this is also the sample prototype for the dataset visualization. And figure number 9 is the map visualization of high and low. And for the results and discussion, so the calculated degree of agreement or kappa value between the generated prediction or the yield of maize by the developed system and the actual yield of maize from the report of the Provincial Agriculture Office was compared by the researchers in order to assess the system's accuracy and dependability in predicting the yield of maize. So the accuracy and reliability of the system in prediction shows that out of 256 instances, 218 were classified as true positive and 37 instances as false negative, and only 1 instance were misclassified. Now, using the Cohen's kappa formula and the kappa value of the developed system, it is computed as 0.9844, interpreted as almost perfect based on the analysis of the kappa value's magnitude. Now, there are 8 independent variables, namely municipality, the year, the month, the variety of corn, area, production, yield, status, and season, and 1 dependent variable called the status. Now, the variable year, area, production are all nominal values, meaning the order or the sequence of its represented data has no bearing or weight in the analysis, and the remaining attributes are ordinal, which means that there is a clear order but no specific unit of measurement in the value it represents. Now, for the conclusions of our study, based on the findings of the study, the following conclusions were drawn. The researchers were able to use and compare the efficiency of performance of the selected classification algorithm implemented using the WECA data mining tool, and the accuracy and reliability of the algorithm used to predict the yield of maize has, as high or low, got a computed kappa value of 0.9844, which is substantial enough to conclude that the algorithm used is reliable. And among the 4 test options in full training set, supplied test set, cross-validation, and percentage split, cross-validation were utilized by the researchers. So the researchers' ideal model, which is the random forest algorithm, was capable to perform well on both the train and test sets. Now, using the random forest in the training set, there are 256 instances predicted as true positive and 0 as false negative, which means that there are a total of 256 out of 370, which is approximately 70% of the total data sets, thus yielding an overall percentage of 100% correct classification. And considering the important parameters of accuracy, absolute error, kappa value, and time to build the model evaluated, that random forest is the best algorithm to be used in classifying the yield of maize in the context of the study. Random forest was considered best, although it ranked equally with JRIP and J48. In case classifiers perform nearly equal, in the study, the best algorithm has been determined to be the one with the highest accuracy and shortest execution time. So in order to further confirm the importance of attribute, the researchers performed attribute evaluation using the CF subset evaluation in WECA into the set of attributes, namely municipality, year, month, type of corn, variety, area, production, yield, status, and season. And it was observed that using tenfold cross-validation, the variable area planting was found to be 80% significant. Now, in WECA, CFS subset evaluation would give merit to attribute which has a higher correlation with the class or the dependent variable and low correlation to other independent variables. And thank you all for listening.
Yeah, good presentation. I have just small question. How you have verified the reliability?
For the reliability, so for the reliability of our study, we make use of the inter-rater reliability.
Okay. Okay. So is there any tool you use or you use manually?
We make use of a software, a data mining tool.
Weka. Okay. Okay. Weka.
Yeah.
Okay. Fine. Fine. Thank you. Thank you.
Okay, thank you.
Yeah.
So we
Harsh,
conclude your. Yes, sir.
yeah, we can conclude now.
Yes, yes. Thank you, presenter. Presentation over here. And now, in the discussion, I sincerely thank our authors for their excellent presentation and great contribution in this session. And I hope all the participants have enjoyed the knowledgeable interactive session. And we, on behalf of whole team, thank you for your support during this version and the previous version of this conference. And we will be happy to have you all in the ninth version of this conference in 2024. Moreover, all the participants will be getting their digital certificates through email within 2 working days, and all the papers have been already forwarded to the Springer. And the publication will be live within 5 to 6 months. So kindly cooperate with Team ICICT 2023 and the Global Knowledge Research Foundation. And just before we end the session, I would like to thank our session chair to chair the session. And sir, there is one token of appreciation to the chair on behalf of Global Knowledge Research Foundation and ICICT 2023.
Thank you.
Yes, sir. Okay, and I think so. Roshan sir is not here, but I just want to show his certificate. Okay, that's it.
Thank you. Thank you all.
Yes, thank you very much.
Thank you, sir, for your presence over
Thank
here.
you.
And thank you all the participants. And just before we end this session, I would like to request you all to turn on your camera so we can capture the good memories of this virtual conference.
Thank you. Thank you, Harsh sir, for nice coordination. Thank you for all presenters for great presentation. All the best.
Thank you, sir. Thank you.
Bye.
I request other participants, if it is possible, you can turn on your camera.
Thank you.
Thank you, sir. Thank you all. Thank you.
Thank you.
Thank you once
Bye.
again, sir.
Bye. Okay.
Bye.